Hello my dears. So in the last class we discussed about differentiator, integrator and what CMRR, that were very important for competitive examination point of view. Especially that problem, it's very easy problem but it is frequently asked. So never skip that session, okay? And today we are going to discuss some more important circuits. Actually in the syllabus now, it's just mentioned that op-amp and different circuits using op-amp. Okay, so the important circuits are we are discussing now: integrator, differentiator, summing amplifier, difference amplifier, etc. We are going to discuss. Okay, so among that, one of the important circuit is op-amp as a buffer. Medias, op-amp as a buffer. So what is mean by buffer? Buffer is nothing but whatever the input we are giving, the same will be given the output. Whatever the input we are giving, the output will be same. Or buffer is nothing but a circuit which simply follows the input. The output simply follows the input. It is known as the buffer. And where we use these buffers are actually, so sir, what is the same output will be given for the input? No, there will not be change in the input. There will not be any change in the output with respect to input. Then what is the use of the buffer? The buffer is used where we are having a situation where impedance matching is necessary. Impedance matching is necessary. I will explain that. Okay. So what is the basic non-inverting amplifier circuit using op-amp? What was that? Basic non-inverting amplifier. Basic non-inverting amplifier. So we are giving input to the non-inverting terminal and we are using R1 and we are using the feedback resistance as RF. Okay, and here we are taken out the output and this is nothing but earthed. So this is the basic circuit of our inverting amplifier, and we know the output voltage equation of non-inverting amplifier because the input is given to non-inverting terminal. That is why the name non-inverting amplifier. Okay, so what was the equation for non-inverting amplifier? We already derived that. What was that? 1 plus RF by R1, right, into V input. So this is the basic equation of what? A non-inverting op-amp amplifier, right? So suppose my dear, what I am going to do, I am making let R1 is equal to infinity and RF is equal to 0. What I am going to do, I am making RF is equal to 0 and R1 is equal to infinity. Then the circuit will be re-modified as, what, my dear? V input, there is no change in that. The circuit will be re-modified like simple, and the same V out will be existing here also. Okay, and whatever the voltage you are existing, the same will be here also. That means the V out will be exist here at the same time, V in also same. V out will equal to V in. I will explain that. That means if I am making R1 is equal to infinity. R1 is equal to infinity means what, my dear? It is open circuit. And I am making RF is equal to 0. RF is equal to 0 means it is simply short circuited. So the circuit will become this like now because it is simply short circuited and there will not be any input impedance. That means Ri will not be there. Ri will not be there. Then what will be the change in the output voltage? What will be the change in the output voltage equation? Normally our output voltage equation was 1 plus RF by Ri into V input. Then now R is equal to infinity, my dear. So the denominator will be infinity and the numerator will be 0. 0 by infinity will be what? 0. So it will be simply V input. Am I right? So what we done here? We simply converted normal non-inverting amplifier using op-amp into the voltage follower circuit. This is called the voltage follower circuit. Voltage follower circuit. Is it clear? And this is used as buffer. And also it is used where used where two circuits to be impedance matched. Impedance matching. Impedance matched. Two circuits to be impedance matched. Whenever there is a two circuits, I will explain now. See, if there is no input resistance Ri mean, then what will be now the input impedance of the what? Our op-amp. What will be the input impedance now? Said input will be nearly equal to infinity. And what will be the output impedance now? Normally an op-amp having output impedance of what, my dear? 0. Nearly 0. Ideal it is definitely 0, but here in practical case nearly equal to 0. So if we have a situation, my dear, if we have a situation where 1 minute power has gone, so I will rearrange my curtains. Okay, so is it clear? Is it visible, my dear? Yeah, it's okay. So what happened if we have a situation where we have two parts of the circuit, my dear, two parts of the circuit, one having high output impedance and other having low input impedance. Then this high output impedance and low input impedance cannot be matched directly. Loading effect will be there. So what we have to do, a separate circuit is inserting in between, which can match the output impedance as the input impedance of the new circuit, and which can match the input impedance as the output impedance of the new circuit. Did you get my point? I will tell you. Simply I will tell you. Okay. I am going to rub this. Okay, my dears. I will rub this and I will tell you. See, suppose I have a circuit, my dears. I have a circuit. I have two circuits, okay. Two circuits are actually. These two circuits I have to match. Okay, one circuit having Z0 equal to infinity. Suppose you imagine. Or Z0 equal to very high. Very high you can. Z0 equal to high. And another circuit having Z input equal to low. If I directly connect this high impedance to low impedance, it is not possible. There will be a loading effect happens and the circuit will lead to so many problems. I mean, the circuitry will not be good in performance. So what we have to do? We have to insert a third electronic circuit, and that circuit should have this side high impedance. So Z input equal to high, and this side low. So if you insert a circuit like this, which having high input impedance and low output impedance, this low and this low can be matched, this high and this high can be matched. That is called the impedance matching. But without sacrificing the voltages or without sacrificing the gain. So now suppose we are using this voltage follower here. Voltage follower circuit. Suppose we are inserting the voltage follower circuit, that is nothing but same buffer here. Then without losing or without sacrificing the gain, what we get? We simply connect the two parts of the circuit. So what is the use of the buffer? It is simply connecting two different impedance or different circuit having different impedances. Okay, two circuits having different impedances. So impedance matching is one of the major advantages of using the buffer. So used where two circuits to be impedance matched, Okay, so that is the use of buffer, my dear. So that is the concept of op-amp as a buffer. Is it clear? Is it clear, my dears? Is there any doubt? Okay. And next we are going to discuss op-amp as summing amplifier. Op-amp as summing amplifier. It is buffer now. So next, summing amplifier. Okay, op-amp as summing amplifier. Summing amplifier. Op-amp as summing amplifier. Okay. Here also we are using the what is mean by summing amplifier, my dears? What is mean by summing amplifier? It has to sum the inputs and as well as it has to amplify the total sum. That is the meaning of summing amplification. Summing amplifier. Okay. Suppose we are applying so many inputs V1, V2, V3, etc. up to Vn. There is a limit actually. So theoretically V1, V2, V3, and it should be added and amplified as the output. That is called the summing amplifier. So here also we are using. The inverting amplifier configuration as the summing amplifier. I will explain now. Okay. Is it clear? Okay, my dears. So this is nothing but our V out, and we are applying here what? Instead of a single input as the inverting amplifier, in the inverting amplifier we are using 3 inputs here. So the output will be what? An amplified version of the what? Input summing, or simply the input to be added up in the output. Okay, let's check is it possible or not by using this summing amplifier. Okay, listen my dear, listen. Suppose I am taking I1 be the current here, I2 be the current here, I3 be the current here, and IF be the current here. Okay, I1 be the current here, I2 be the current here, and IF be the current here. And I can apply KCL here, my dear. Apply KCL here. So apply KCL. What I get? I1 plus I2 plus I3 equal to what? IF. Am I right? Then what is this I1? To virtual ground or virtual short property. See, suppose this is 0 volt because it's grounded now. So there here also exists 0 volt. Here also exists what? 0 volt. Okay. So what is I1 now? I1 can be written V1 minus 0 divided by R1 plus V2 minus 0 divided by R2 plus V3 divided by C minus 0 divided by R3. Am I right, my dears? Equal to IF. IF is what? 0 minus V out divided by R. Or simply V out is equal to what, my dear? V out is equal to minus of RF by R1 into V1 plus RF by R2 V2 plus RF by R3 into V3. Am I right? Am I right? If RF equal to R1, okay, if RF equal to R1, then what will be the output? V out is equal to minus of RF and equal to R2 equal to R3. Okay, if RF is equal to R1 equal to R2 equal to R3, both are same, everything is same, which is nothing but R. Okay, if you take RF is equal to R1 equal to R2 equal to R3 equal to R, then what will be the output? Minus of RF and R1 same, no? Both are equal, and which is equal to R means R and R get cancelled. V1 plus V2 plus V3. Is it clear? Is it clear? So this is one case. This is one case. Okay. This is one case. So the answer will be nothing but, my dear, summing. The answer will be nothing but summing. Next one. In the same circuit we are using for averaging also. I will explain that also. Okay. I will explain that also. If RF R1 equal to R2 equal to R3 equal to R and RF by R is equal to, let be 1 by N. Imagine. Okay, let be 1 by N. Where N is equal to nothing but, my dear, number of input. Suppose I am taking R1 equal to R2 equal to R3 equal to capital letter R and RF by R will be nothing but 1 by N. Then my Vout will be nothing but, my dear, minus of, normally what was the equation? RF by R, RF by R. Am I right, my dears? RF by R into V1 plus V2 plus V3, which is nothing but, my dears, minus of, what is this RF by R? 1 by N into V1 plus V2 plus V3. See, Vout is equal to, and this is nothing but, my dears, averaging. Am I right now? V1 plus V2 plus V3 whole divided by 3. We are here, N is equal to what? Number of input. Here 3 input. So V1 plus V2 plus V3 by 3 is nothing but what? Averaging. Is it clear? So now you got summing and here you got averaging. Okay. And listen, one more thing I will show you. If R1 equal to R2 not equal to R2 not equal to R3, okay, both are not equal, then the output will be nothing but, my dear, minus RF by R1 into V1 plus RF by R1 into V2 plus RF by R1 into V3. Normal case, RF by R1 into V1, RF by R1. Let this RF by R1 is nothing but, my dear, let be taken as A into V1. Okay, and RF by R2 and R3. Sorry, my dear, it's both normally equal. It is not equal now. So RF by R1 plus RF by R2 plus RF by R3. This RF by R1 let be A, and RF by R2 let be B, and RF by R3 let be C into V3. So what do you get now? What do you get now? Okay, what do you get now? This is nothing but, my dear, amplified summing or scaled sum. You can correct, you can say like scaled summing. So by using this simple circuit, a single circuit, my dears, you can make summing, simple summing, averaging and scaled summing also. So that much will not be asked, but anyhow you just familiar with this circuit. Okay, so that's all about the summing amplifier. Next we will discuss about difference amplifier. Differential amplifier. Op-amp has the differential amplifier. Op-amp has differential amplifier. Op-amp has differential amplifier. So what do you mean by differential amplifier, my dears? Differential amplifier is nothing but the output will be the difference of the input plus the amplified version. That's all. The output will be the difference of the input as well as the amplified version of the input. So let's see how can it be formed. How can it be formed? No need of this, you can directly connect it to like this. This is RF and this is R1. RF and R1. Or simply you can take R2 and R1. No issues. R2 and R1. This is nothing but my V out. This is V1 and V2. Okay, that's all. That's all. Okay, listen. So op amp as a differential amplifier. How can we use it? The op amp as a differential amplifier means nothing but, my dear, it is a combination of, it is the combination of inverting and non-inverting amplifier. Inverting and non-inverting amplifier, which means here we are applying the input to both the terminal, the input terminal, I mean inverting terminal as well as the non-inverting terminal. So the expression for V out can be obtained by superposition principle. The output equation can be obtained by what, my dear? Superposition principle. Okay, and equation will be nothing but, we don't want the derivation and all. The V out equation will be nothing but, my dear, R2 by R1 into V2 minus V1. Only this expression you can remember. So this is nothing but, my dear, R2 by R1 will be a scaling or the amplified version. R2 by R1 will be, suppose you can take it as A. Okay, so it will be A into V2 minus V1 is nothing but difference in voltage that we applied. Okay, and let us do a problem which demonstrate how can we use this differential amplifier circuit and how can we apply this superposition principle and all. Okay, the problem is very important. The problem may be asked, a circuit may be given and find out some terms, I mean unknown, V out or RF or R1, anything, any miscellaneous term you have to find out. Okay, let's find it through a problem so that these things can be more clear. Okay, my dears. Okay, let's do a problem. Let us do a problem. Listen. Okay, our question is find the V out. Find the V out. So how can we find the value of V out? Let's do that. Okay, so applying superposition principle. Okay, apply superposition principle. So what is mean by the superposition principle, my dear? We can only consider a single source at a time. So I am consider only 2 volt at a time. 2 volt at a time means 3 volt will be equal to 0. I mean there will not be any voltage here. If there is any voltage, if there is not any voltage here means this thing cannot be exist. This cannot be exist here. It's simply like a grounded path, na? But different impedance grounded path, but eventually it is a grounded now. So it is like what? The circuit like this. If we neglect this means the circuit will be like this. That means it is like an inverting amplifier. So let the output voltage be V01 if only 2 voltage exists. Then what will be the output V01 equation? Then nothing but minus RF by R1 into VA. Am I right? So which is nothing but my dear minus 5 by 1 into 2. Which is the minus 10 volt. Minus 10 volt. Next case, consider only 3V volt. Then 3 volt. So that this 2V volt source will be equal to 0. Then what is the voltage source equation? V02. What will be the V02? If this is not there means it is like the non-inverting configuration. So non-inverting configuration means what, my dear? But you have to note one thing. If there is no 2V, this 2V is not there, which cannot what indicate that this RF is not there, this RA is not there, because once feedback is connected means there will be some connection. In the case of this circuit, if we neglect 3V means we don't want anything regarding this one, because there is no input at all applied. It is simply like an earther portion. It is simply like an earther portion. But here it is, if we neglect this 2 volt means, if we neglect this 2 volt means what? It doesn't mean that we cannot consider everything. You have to consider, because once upon there will not be any grounded, direct ground, it is all. And second one, there is a feedback connection. So we can't omit everything. We can't omit everything. Okay, I will tell you. So if 2V equal to 0 means it is like what? A non-inverting amplifier. Am I right? If 3 volt is not there means it's like an inverting amplifier. If this 2 volt is not there means it is like a what? Non-inverting amplifier. So what is the equation for non-inverting amplifier, my dears? 1 plus RF by R1 into V input. Am I right? So which is nothing but 1 plus, what is here RF and R1? 5 divided by 1 into V input is nothing but in a non-inverting amplifier equation, I mean circuit, if you check that, you can find that directly you can connect it. Directly you connected the non-inverting terminal to the V input. But now through some resistors are there. So what will be the voltage here? Let be V plus. So that V plus will be instead of V input. Am I right? So what is this V plus means? It is nothing but, my dear, 1 plus 5 by 1 is nothing but 6 into V plus is nothing but 3 into voltage division rule. V plus is nothing but voltage across this portion, which is nothing but the voltage across this 8 kilo. Am I right? Voltage across this means voltage across this and ground. This and ground is what resistor is connected? This and ground. 8 kilo ohm is connected. So voltage across this means nothing but voltage across this 8 kilo ohm. So which is nothing but 3 into 8 divided by 8 plus 1, which is nothing but 9. So if you do this, so it is nothing but, my dear, 16 volt. Is it clear? So what will be final V out? What will be final V out? It's equal to V01 plus V02, which is nothing but, my dear, minus 10 plus 16, which is nothing but 6 volt. 6 volt. Okay, and check one thing very important. If you finally obtained some voltage like 6 volt, okay, fine, and always check that 6 volt is less than this plus or minus VCC. It's less than this plus VC and less than minus VC. You have to check that. Suppose you got an answer like final V out is equal to 16 volt. Imagine some answer you got, that means some resistance are arranged in such a manner that you got an output of 16 volt. Then what will be the output, actual output? The actual output will not go beyond this plus VCC if it is positive, and the actual output will not go beyond minus VCC if it is, the answer is negative. So now you got plus 16. You imagine, suppose you plus 16 you obtained. Never write this as a plus 16 as the final output. you will get, it is not right answer, and the right answer is nothing but, my dear, 15 volt. Because whenever the value of the output voltage is greater than the V saturation value, then the output voltage you should take like V saturation. Because in the op-amp characteristics we already obtained, like, what was the characteristics on op-amp? This was the characteristics. The op-amp maximum voltage will be plus V sat and minus will be minus V sat. So in between there should be the values. So if you got any value which is greater than the V sat, the output you should take like plus V sat or minus V sat, depending upon the sign of the output voltage. That's all. So that's all about the op-amp as the differential amplifier. Okay. Okay. So that's all for today, my dears. So let's continue with some more important topics in the next class. Okay. Thank you.